Yeah, welcome back. We have reached the final topic for this course, yeah, which is how to actually implement friction. Yeah, friction is not applied using force, even though we know friction is actually force, yeah, but we don't actually call the add force, yeah, from the rigid body, but we will set up any frictions using physic material, yeah. Okay, it is not a typo here. Yeah, please ask Unity themselves why they decide to call it physics and not physics. So to create a physic material, uh, to manage your project, so it will not clutter with some random assets. Yeah. Please create a new folder now on your assets, name it materials, and then right click it and select create physics material. We will name it hard surface. Yeah, let's do it. Okay, open your asset folders and then create a new folder. Let's call it materials. Materials. Okay, open it and then right click again, create physics material. Yeah. As you can see here, we have a 2D counterpart, which is physics material 2D. Yeah, you can search online why they call it physics material for 2D, but for the 3D version is physics material. Yeah, please. You can ask Unity for this. Yeah, for now, we must accept it as it is. Okay, create a new physics material, name it, for example, like hard surface. And then take a look at the inspector for your physics material. Yeah, as you can see here, you can set your dynamic friction and static friction. Yeah, this is the mu k and mu s. Yeah, dynamic is the dynamic friction is the same as the we call it kinematic friction coefficient. Yeah, mu k. In the meantime, static friction is mu s. Okay, as you can see here, the valid values are from 0 to infinity. Okay, you can also find the bounciness here. Yeah, so we talk about two topics. Yeah, in the same video here. Yeah, there is the friction and momentum as well. Yeah, the bounciness is the efficient of restitution. Yeah, DE, if you remember from the week 6 or week 5. Yeah, I think. Yes, so the bounciness is the elasticity of your game object. Yeah, the valid value are from 0 to 1. Okay, in the meantime, for the friction or the bounce combine, yeah, this is used to calculate the result from when the two game objects actually friction has friction with each other or bounces. Yeah. If you set it to average, which is the default, then Unity will calculate the average from the two physics material. Yeah, if you set it to maximum, then the maximum value will be used. Yeah, minimum is the other way. Yeah. Oh, sorry, this is flipped over. Yeah. For the maximum, we use the maximum values. For the minimum, we use the minimum values. For multiply, then we can just simply multiply both physics materials. Okay, so for example, please create a plane and a box on top of it. Yeah, I will use the same scene. Then I will create a plane here. I will move it so my car is still visible. Yeah, although we no longer need our car. Yeah, goodbye car from now. And then add some box. Yeah, a box, a cube on this plane. Yeah, later you can just simply give it a rigid body and we chooses use gravity turn on. Yeah, so you don't really need to set up this box to be right on top of the plane. Yeah, you can just leave it have a very small gap like this. Yeah, and let Unity take the rest. Okay, for the plane, I will apply the hard surface material. Yeah, to apply a physics material to any game object, then you look or find the collider proper component from your game object. Yeah, and then find the material property. Yeah, here it says none physics material, so you can simply drag this hard surface to the material field. Yeah, it's very simple. Oh, let's say for the static friction, I will change it into say 0.8. For the dynamic friction, I will set it to 0.7. Yeah. Now, how to test this friction? Yeah, we must create a movement for this cube or this box. Yeah. So I think I will scale my plane first. Yeah. So it will be longer, something like this. And I will leave my cube here. Yeah, I will leave my cube here, and then if you want, you can also apply another material, yeah, physics material for your box. Yeah, but I will leave it like this, and then I must move my cube, yeah, by using some force. So let's see if we have any available script that we can use. I don't think we have. So okay, let's just create a script now. Yeah, I simply call it move and I attach it to my cube. Oh, sorry, it is not hasn't finished compiling yet. Let's wait now. Okay, I will attach it to my cube and then I will give it some boost here. Public factor 3. I will just use the velocity. Yeah, velocity and private rigid body RP. RP equals to get component rigid body. Oops. And RP dot velocity equals to the not vector 3 velocity. Oops, velocity. Okay. Update. I will delete it. Yeah, and then I will give my cube some velocity, initial velocity to the z axis. Let's say 3. And then, oh, I will give it also rigid body, yeah, rigid body. I use gravity. Let's see the result. Oh, okay, it only moves for a brief time. Let's try again. Yeah, it only moves for a brief time. Then let's increase the velocity, 10 maybe. Oh, it flips over. Yeah, it flips over. So, okay, let's see. Yeah, it actually flips over because I actually uh, I do not constrain the rotation. So let's say I don't want my box to rotate in any ways. Let's disable my curve. So, oops, sorry, no camera rendering. Oh, because my main camera is here. Yeah, I will move it out temporarily and disable my car first because I want to focus on this box. Okay. Now, as you can see, it moves. Yeah, initially, but due to the friction, then it will stop. Yeah. If you want to do something like this, then you can actually move the cube. Yeah. And by pressing Control, you can snap it to the grid. Yeah. Yeah, something like this. Yeah. Although actually there is still some gaps. Yeah, very small gaps here in the between my plane and my cube, but I think that's fine. Yeah, as long as my cube is still uh, above the plane. Yeah, don't position it so that your cube actually collides with the plane because you will create uh, undesired effect. Maybe something like this. Oh, because I have already frozen my rotation. Yeah, so it does not wildly react with the collision. Yeah. Okay. So for friction, it is as simple as creating a new physics material. Yeah. For the momentum, it's the same. Yeah. So I will leave an exercise for you for now. Please recreate collisions between two moving objects. Yeah. Either using cubes or spheres, or also you can try a bouncing ball. Yeah. Please try to set up for elastic, inelastic, and real collisions. Okay, so I will give you only one example. Yeah, I will recreate the bouncing ball. Yeah, after that, please do the collision between two moving objects by yourself. For the bouncing ball, I will create a sphere here, and then I will move it uh, above the plane, and then I will add a rigid body component. I will lift the mass one and make sure that use gravity is checked. And I will create a new physic material for my ball. Yeah, let's try the bounciness. Yeah, if my bounciness is 1, what will happen? Yeah, and don't forget to apply the physic material to your collider. Yeah, here because it is sphere, so it is called a sphere collider. Yeah, but you can still find the material property. Yeah, apply the material, the ball physic material. Yeah, and then check for the bounciness. It is 1, but the bounce combined is still average. So because it is average between the ball and the plane, yeah, which the plane has a bounciness of 0. So the next bounce, I will move it to round y. Yes. So for example, 6, the the bounce of the ball will not actually reach 6. Yeah. Let's try it. Oh, sorry. The the cube actually interferes with my my ball. So it is it still above the plane? Yeah. If the shadow is correct, then it is still above the plane. Let's just try it. Yeah, okay. Yeah. We create the effect of a bouncing ball. Yeah, but since it is average between the ball and the hard surface, as you can see here, the bounciness of the ball is 1, but the the bounciness of the hard surface is 0. So if we average it, then we can expect that it will not bounce to the maximum height of 6 as we do in our C# code. Yeah, and actually it will move only about. Let's try it again. Okay, roughly up to y equals to 2. Yeah, let's see. Yeah, and then it will move back again to it will fall again. Yeah, and then it will bounce only for a brief y, then it will actually still in place. Okay, now let's try another bounce combine. What happens if the bounce combine is a minimum? Let's try it. Okay, you can see here my ball does not bounce at all. Yeah, because the minimum of the bounciness is 0. Yeah, if you remember from the topic of the momentum, if you have E equals to 0, then it will stick immediately. Yeah, and the ball will not bounce at all. What about multiply? Yeah, but if we try multiply, then bounciness 1 and bounciness 0. If we multiply 1 by 0, it is also 0. Yeah, so the result is still the same with the minimum. Yeah, let's say if the hard surface has the bounciness of 0.5, what happens to our sphere now? Yeah, it will still bounce, but since it is multiplied, then we will get this result. Yeah, the last one, if we try the maximum, yeah, what is the result of having a bounce with a bounce combine is the maximum. So now if we have the bounciness of 0.5 and 1, it will pick the bounciness of 1. Yeah, let's take a look at the result. Okay, as you can see here, then this is the maximum bounce, yeah, applied to my ball. But remember my statement that the physics engine in game engine, yeah, uses as approximates only. So sometimes the result is not correct. Yeah, as you can see here, my ball bounces higher and higher, which is not possible in real life. Yeah, and even by physics definition, it is not possible. Yeah, so this is called some error. Yeah, but it is actually very common in physics game engine. Yeah, so that's why sometimes in games you may see some strange result. Yeah, because the physics is not accurate. Yeah, it strives for speed over accuracy. Okay, so it is that was the demonstration of creating a bouncing ball. Yeah, I will leave it here for the to create collisions between two moving objects here for you to do on your own. Yeah, then you can also try for inelastic and real collisions. Yeah, please do it by yourself. If you have any problems, any questions, then you may ask on the comments below, or you can contact me on the Google Hangouts group chat. Yeah, or you can also ask at your assistant. Okay, so I think that's all for today's course. Yeah, we have already implemented a lot. Yeah, and actually we squeezed the first half of the semester into just one course. Yeah, which I think it's only less than 3 hours. Yeah, 3 credits. Yeah, I hope you enjoy this course. Yeah, and uh, you will experiment using physics in Unity. Yeah. So for now, thank you for watching, and we will see you at the next topic.